Hello, everyone. Thank you all for being here. I am Chen Yu-Ku, Vice President and Distinguished Professor at National Taiwan Ocean University in the Department of Harbor and River Engineering. It is my great pleasure to introduce the Center of Excellence for Ocean Engineering, the CEOE. Over the next 10 minutes, I will walk you through who we are and how we are organized and set out our core objectives. I will then highlight our world-class research facilities, our key industry, government, and academic partnerships, and our international collaborations. After that, I will share several of our representative research focus areas and projects, and show how, together, they advance Taiwan's marine-oriented sustainable energy development and its 2050 net zero goals. Let us begin. Let me begin with our objectives, which center on advancing Taiwan's 2050 net zero transition. The Center has signed a Sustainable Energy Initiative Declaration with the Taiwan Institute for Sustainable Energy, and we align our work closely with the Executive Yuan's Sustainable Energy Policy Framework. To deliver on this, we have built an industry, government, academia collaboration platform dedicated to a marine-oriented sustainable energy center. Our facilities are exceptional. We host Asia's first ocean engineering experimental hall with irregular wave generation capability, the only such facility in Taiwan, together with the world's third largest cavitation tunnel laboratory. We are also establishing marine energy test facilities, including an ocean energy test site, onshore wind turbines, corrosion testing platforms, and wave buoy systems. Leveraging the university's marine research strengths, we are driving sustainable marine energy and low-carbon green energy development. Let me turn to the facilities that underpin everything I have described. We operate the research vessel, New Ocean Researcher No. 2, representing an investment of more than 400 million new Taiwan dollars. We have an onshore wind turbine test site and a large cavitation tunnel laboratory that is Taiwan's only such facility and the third largest in the world. Our ocean engineering experimental hall is the largest in Asia and the fifth largest in the world. We also operate autonomous underwater vehicles for marine survey work, and we host a ship handling simulator established by the Ministry of Transportation and Communications with an investment exceeding 200 million new Taiwan dollars. Taken together, these international class resources place the center among the world's leading marine research environments and form a genuine integration platform for sustainable energy development. Collaboration is at the heart of our progress. The Center has established 6 key sustainable energy technologies, advancing development that is more efficient, higher in value, lower in emissions, and less dependent on imported energy. NTOU has signed a Memoranda of Understanding with the Geological Survey and Mining Management Agency of the Ministry of Economic Affairs on geothermal exploration, with the Taiwan Green Energy Application Association on marine-oriented energy development, and with the Sinotech Foundation for Research and Development. We are also collaborating with Jiguang Energy on aquavoltaics and solar photovoltaic systems. These partnerships span geothermal exploration, hydrogeological investigation and modeling, and the development of innovative, diversified marine renewable energy technologies, reflecting NTOU's significant strength across the sustainable energy field. This network gives us both the resources and the reach to move research quickly from the laboratory toward real-world application. Our reach is genuinely international. We collaborate closely with leading scholars abroad, Professor Frank T. C. Tsai of Louisiana State University, Professor Alexander H. D. Cheng of the University of Mississippi, and Professor J.S. Lin of the University of Pittsburgh, and the Center has secured formal letters of consent from each of these international research collaborators. Our joint work spans topics such as land subsidence and saltwater intrusion in coastal plains, statewide groundwater model development, and the U.S. Department of Energy's subsea methane hydrate program. We have also signed a Memorandum of Understanding with Can Do University in Vietnam, and we are working with the ambassador of St. Lucia to advance talent development. These relationships, formed largely from 2021 onward, continue to strengthen our global networking and joint research. Now, let me share several of our representative research focus areas. The second is the geological disposal of radioactive waste beneath the seabed. Here, we conduct groundwater analysis for the subseabed geological disposal of spent nuclear fuel in offshore islands, geological and host rock assessment for nuclear waste disposal sites, and a feasibility assessment of high-level and low-level radioactive waste disposal in Taiwan. Our work addresses both the high-level spent nuclear fuel disposal process and the low-level radioactive waste disposal process. Through these efforts, we are promoting subseabed geological disposal and advancing low-carbon nuclear energy assessment. This is carried out as an international, inter-university, and interdisciplinary collaboration with the Energy Center of the University of Pittsburgh and with the Sinotech Foundation. Together, these achievements give Taiwan an important evidence base for the safe, long-term management of radioactive waste. The fifth focus area is island-type geothermal energy assessment. We are promoting offshore volcanic geothermal exploration along the Waimushan coast of Keelan, including the Shinsei active volcano, to evaluate Taiwan's island-type geothermal potential. Our approach integrates offshore geological, geophysical, geochemical, and drilling data through artificial neural networks, allowing us to build a far more complete picture of the subsurface. We then assess generation potential by analyzing caprock, reservoir, and heat source characteristics, and we are developing techniques. Building on these results, we are working to advance commercial geothermal energy development in Waimushan, the Datung Volcanic Group, and Guishan Island. If successful, this work could open a clean, stable, and domestic baseload energy source well suited to Taiwan's volcanic island setting. The sixth focus area covers marine wave energy and ocean thermal energy conversion. Our project achievements here include the development and application of a small-scale wave energy converter integrated with IoT buoys and fish cage systems, research on ocean thermal energy conversion in Taiwan, and work to improve the accuracy and efficiency of three-dimensional ocean modeling. We have built a system architecture for an offshore AIoT monitoring platform, together with a multi-purpose platform that integrates aquaculture cages with a floating point wave energy converter. By combining energy generation with aquaculture on a single platform, we make the most of limited ocean space. Through these efforts, we are advancing marine renewable energy technologies, including wave energy and OTEC, and directly supporting Taiwan's sustainable development goals through green energy innovation. This slide summarizes our representative research accomplishment, spanning two themes: marine energy and river and marine disaster prevention. On the marine energy side, our flagship project is the exploration of deep-sea clean energy, phases 3 and 4, funded by the National Science and Technology Council from 2022 to 2026 at NT dollar 23.4 million. Related efforts include an industry-academia collaboration on geothermal reservoir exploration in the Chunyang area with Gaia Lights Energy at NT dollar 8.8 million, and an assessment of offshore wind farm development and maintenance with China Steel at NT dollar 8.3 million. On the disaster prevention side, we lead the Keelang City Resilient Taiwan program for large-scale typhoon and earthquake preparedness at NT dollar 13.5 million, alongside projects on extreme weather impacts on harbor structures, oceanographic surveys, water quality improvement, and firefighter occupational safety. Together, these demonstrate the breadth and funding strength of our research. That brings me to the end of my presentation. To summarize, the Center of Excellence for Ocean Engineering brings together world-class research facilities, strong industry, government, and academic partnerships, deep international collaboration, and a broad portfolio of projects, all directed toward advancing Taiwan's marine-oriented sustainable energy development and its 2050 net zero goals. We believe the center is well positioned to serve as a national platform for ocean engineering and sustainable energy research in the years ahead. It has been a privilege to share our work with you today. Thank you very much for your attention, and I will be glad to take any questions you may have.